Should you use consumer activity tracker in research? So you have a research project and you need to track physical activity. Should you use Fitbit or other consumer activity trackers? After all, they are easy to use, are available everywhere, are not particularly expensive, and companies have poured millions and millions to develop them. So why wouldn't you use them rather than more costly research-specific devices? So in this video, I'm going to go through many different things from many perspectives, and probably there are many things you haven't considered. It is actually quite easy to fall into the trap of thinking that because devices are easy to use for consumers, that they would actually be easy to use also in a research project. I have done a study with 10 consumer activity trackers myself, and in the end of the video I will tell some insights and what I learned from that project. But before that, let's go into the details whether or not you should use a consumer activity tracker in your research project. So there are quite many things to consider. Basically, consumer trackers, they are easy to use. Like, many people are using them and they are able to use them. So you would easily think that they are easy to use. But if you think about it, they are designed for consumer users. So they need smartphone application. If you create a research project, are all of your participants able, willing, or so on to actually install a new application to their phone? Also, these devices usually don't have too much memory for data locking, but they are designed for real-time communication, usually via Bluetooth, and Bluetooth is actually draining the battery quite fast, so you need to charge the device often, or otherwise you are losing valuable research data. So if you compare that to a research device which doesn't have any buttons, has up to 3 months operation time, doesn't need any interaction between the device and the smartphone, but everything happens automatically, you might want to reconsider which one is easier to use. And also continuing on this, consumer activity trackers are designed for personal use. So basically the smartphone application is designed for personal use. So the person will see the data, but how easy it is for researcher to actually get the data from a personal smartphone application to their hard drive or cloud server. So that's much more challenging, and usually people or participants need to register with their email and give their information. So it's much more difficult usually to get the data to the researcher than you think intuitively. And in this, if you're running a large-scale study, even small things can make a huge difference. So think about, how do you really manage the data? If you're just testing it by yourself, like many researchers do before starting a project, you have your smartphone application, you click expert and it all goes out. But are participants willing to give their phone with all the personal information, even for a moment, to a researcher who would upload the data or download the data? That's a different thing. And then you would need to actually meet physically if it's not uploading to the cloud. If it's uploading to the cloud, for example, of the brand, how do you access this service, the participant information? Or can all participants actually register for a project that the data will be collected into that? So think about these things and really test it with outside participants before you commit yourself to certain device. Also, related to this, in research project, you want to control when do the participants see the result of the measurement. So many times you want to, for example, do baseline measurements, and you want that the participants won't see the results because you want to get the real picture, not influenced by the feedback. And sometimes you want first to hide that the people won't see the results, and then you want to release them in a certain time slot, and then, for example, that they don't see again. Or this might be different between intervention group and control group. So you need to be, in most of the research settings and designs, you need to be able to control that. And with consumer activity trackers, that might be really difficult because they are designed in a way that participant or the user in a way will see the results basically at any point when they just open the smartphone app. So this is also something you should consider. And then if we move from usability things more to algorithms, so usually in consumer activity trackers, the algorithms are proprietary, meaning that they are trade secrets of the company. Companies consider that they are usually the secret sauce of the company, so they are not providing information, many times even what variables are in the equations, and definitely not how those equations are, because otherwise competitors could copy their information or their algorithms. So we are talking most of the time fully black box approach. So you don't know how the analysis is being done. And there's actually an interesting story on this. There was a brand who had a heart rate monitor, and they were estimating fitness level based on the measured resting heart rate. And it seemed to work pretty well. You fill in the background information, you do a resting heart rate measurement, and it was estimating quite well what is the fitness level of a participant. It was giving a VO2 max value or estimation of VO2 max value, but actually when researchers were testing it more closely, basically the fitness level estimation was defined from the background information that how many times a week you exercise. And the measurement of heart rate had only minimal effect on that. So it was quite a big finding, because you might not know whether participants are actually truthfully giving that background information, and you might get the false sense that it would actually use the resting heart rate in the algorithm and it would make the difference. So a little bit different story than tracking physical activity, but tells the example of, well, that when you have a black box, you don't know what the algorithm includes, it can be challenging in research projects. And other important thing related to algorithms is that companies are usually not telling when do they change the algorithms. Even if you have the same hardware, the same device on the wrist of the participant, it might change in the cloud or when you upgrade the firmware of the activity tracker. And this is especially problematic when you have intervention studies or in general longitudinal studies. You don't know if the algorithm has been the same in the beginning of the study and in the end. So all effects you see in the study might be actually because the algorithm have changed. And there are some experiences of this in the studies, and sometimes researchers might not even notice that the algorithm have changed. So then you actually reporting effects which are not real. We are discussing this in the podcast episode, in Physical Activity Research podcast with, for example, with Dr. Alexander Montoy, who is a specialist with the activity trackers and accelerometers. So if you're interested in the theme, check the episode with him. And last but not least is the validity of an activity tracker. And many times there's a lot of studies of validity, but pay attention how the studies are done. Many of them are done on a treadmill, that participants, for example, walk with certain speed, then the speed is increased, they walk faster, then the speed is increased again, and then it's easy to see that why it seems that the detection of intensity, for example, work, because you start walking faster, your arm moves faster, and the device is detecting that. Also, same goes for steps, because you are just walking directly on a treadmill. But if you compare that to daily life, where we are walking up the stairs, we are turning, we are stopping, we take few steps there, and most importantly, we are many times moving our wrist without moving our legs. So that's when quite often the devices are measuring steps even when you are not taking steps. And also, same thing can happen, for example, when you're just sitting in the bus is bouncing, so your activity tracker is detecting movements, and if that fits to the kind of rhythm of the walking, it might be detecting steps when you are just sitting. So many times the validation studies give a better picture of the validity than what they actually really measure. If you want to see the real validity of the devices, try to find studies which have used simulated daily life, where people have actually been moving normally, and that has been compared to direct observation. Also, with sedentary behavior variables, if you have a wrist-worn device and it's saying that it's measuring sedentary behavior, usually what it is measuring is a lack of movement, which sometimes is the same as sedentary behavior. You sit down, you don't move at all, and then you start walking, you move. But basically, if you think, how do we sit most of the time in the day? We are, for example, working. We are moving our arms. So basically, it's not staying still, even though we are sedentary because we are sitting. So that will go wrong. Then it's, for example, when we're eating, again, we are moving our arms, but we are sitting. So that also goes incorrectly. And if this is done in a validation study, that people are asked to sit down and not move their hands, they are sitting, that's not how it is in normal daily life. So you might have validation results which seem good but are not actually the same in the daily life settings. So quite many things we have considered, and then the question when to use consumer activity trackers in research. So if you are doing research on consumer activity trackers, you want to find out, for example, how they change behavior of people, can they actually increase activity, then naturally you should use them. Or if you're aiming for behavior change from feedback or some sort of alerts, for example, from inactivity or lack of physical activity, then I would say that you can consider using consumer devices. But most of these problems I mentioned before will still apply and might be a big headache in your project. And even in this behavior change setting, there are practical and easy to use devices that are designed for research purposes. So I would recommend using them rather than consumer activity trackers. And in all other cases where you really need information and data of sedentary behavior and physical activity, I would really recommend using devices designed for research, validated in proper setups, especially using thigh-worn accelerometer, as it's measuring actually the sedentary behavior and can do posture allocation correctly. But in all other cases where you actually need data from sedentary behavior, physical activity, I would really recommend using a device that has been designed for research use. These devices provide better validity, which is really important in a research project, and are actually easier to use from the project point of view, because it has been designed in a way that it's easy to get the research data. Especially now there are devices that you just give to participant, you can control them remotely, data is uploaded automatically with the GDPR proof ways, and during the project you can easily check that the data is going correctly, devices are waterproof, and you don't need to charge them. The measurement time can be up to 15 weeks without charging the device, so I think it's a no-brainer to use actual devices that has been designed for that purpose. And before we finish, I promised to tell experiences from my own research project, which included 10 consumer activity trackers. I can condense it to one word. The project was a nightmare. We did it even in a lab, so it's easier to manage than field condition, but still there was so many problems. We just not could upload the data from the tracker to smartphone or get the data out of the smartphone. We probably had all problems you can imagine, and many of them just could not be fixed despite our best efforts. And then we had all the reviewers complaining about missing data. So my personal advice for you is to think twice before starting a project with devices that are not meant for research use. Hopefully this was helpful. Probably some people agree with me on this issue, some people might disagree, so feel free to leave a comment below. Glad to hear all opinions, and also if you have any suggestions for new videos, leave a comment and I will see if I have time to make a video based on your suggestions. Thanks for watching and have a good day.